So still in the question number 2, we need to show that modus ponens is a tautology. So what is this modus ponens? This is a method of affirming, which is written like this: P and P imply Q. They only imply Q is a tautology. This statement is always true. We can read it as follows: if P then Q, if P then Q. If we have P, therefore we have Q. P imply Q. We have P, therefore we have Q. Makes sense, right? How we prove this is a tautology. So this equivalent to, okay, let's think about this as follow. This is a big P statement. This is a big Q statement. P imply Q, and we know that P imply Q. We did prove this before, that P imply Q is equivalent to not P or Q. Almost all the time I use this equivalent. I will try to remove all the implication and rewritten them as or N, or N. Okay, let's do that. So big P imply big Q is equivalent to not P imply Q or Q, right? This is equivalent to not, okay, let's do this, not P or not P imply Q or Q. Does this make sense? So now I just delete this bracket, not P, and become O, not P or not P imply Q, and we didn't change anything here, or Q. Okay, what next? This is equivalent to not P, and just a comment, this bracket is not necessary. The reason because the operation between them is or they're the same. By associative properties we can even remove this, still correct. Okay, so we have not P or not P imply Q would be equivalent to not P or Q or Q, right? In this step I only change P imply Q to not P or Q. Then we continue, not P or not P, right? So P and not Q or P. Does this make sense? Not P, which is P, not Q, which is not Q, or become N. Okay, what do we have here? Look, in this step we see that A big A or B and C by distributive properties. Maybe let me recall it here. A or B and C is the same as what, or equivalent to A or B and A or C, and we use this. I'll put it here. This is the same as not P or P and not P or not Q. These brackets say that we do this operation first, right? And now we have or Q. Okay, so this step I use distributive properties. A is not P here, not P or P, not P or P, and not P or not P or not Q. Okay, not P or P is a tautology. It's only true. Not P or P. It must be only true. This is a tautology. A tautology and something. Maybe another recall. Let me write tautology at T. Stand for tautology. A tautology and a statement P is equivalent to a statement P. Reduce that. There. So we have this is a tautology and a statement which is the same as this statement itself. Not P or not Q. We only have the OR operation, so we can remove the brackets, right? Because it's associative properties, only OR. So this is the same as delete the brackets. And okay, just give itself and do associative by doing not P or not Q or Q. Right? Not Q or Q. So here we have not Q or Q is similar before. Here we have not Q or Q is a tautology, and which makes this one is which is a tautology. And therefore this statement is only true. So modus ponens is a tautology. Modus ponens is a tautology, and here's one way to prove it.